Hello students, welcome to the online session of database management system. In last session we have studied about transaction, acid properties of transaction and transaction control language commands, that is commit and rollback. In today's session we are going to study about states of transaction, concurrent execution of transaction, advantages of concurrent transaction execution and problems in concurrency. The learning objectives are: after learning this session, students will be able to describe the states of transaction and students will be able to describe the concurrent transaction execution concept. So first we'll start with the states of transaction. A transaction goes through different states throughout its lifetime. That is, from starting to end, transaction goes through these number of stages given in a diagram. So the stages or the states are active state, partially committed state, failed state, committed state, aborted and terminated. Okay, so these are the 7 states or these are the 7 stages through which a transaction goes, okay, from starting to end. Now one by one we'll see each of them in detail. This is called as a state diagram of transaction. So first state in transaction is active state. When the instructions or the commands of transactions are executing, then it is in an active state. That is, whenever any read, write or update command in transaction is in running mode, then we can say the transaction is in active state. Then next state is partially committed. After successful execution of last instruction of a transaction, it enters in a partially committed state. That is, whenever we execute a last instruction of transaction successfully, then we can say that the transaction is in partially committed state. Here in partially committed state, whatever changes done by read, write or update operations in transaction, all those changes are stored in main memory. They are not directly stored in hard disk or they are not directly applied on actual database. Whatever changes done by transaction instructions, they are first written in a main memory and then they are carried out on actual database. Okay, so in partially committed state, the transaction has completed its last execution successfully, but the changes are not stored in actual database. They are in main memory, they are in local buffer. That's why it is called as partially committed state. Okay, then the next state is failed state. So during the execution of transaction, if transaction fails due to any hardware or software problem, then it enters in a failed state from active state. See, whenever a transaction is executing instruction, then it is in an active state. But while executing those instructions, if that transaction fails due to any problem, then that transaction enters in a failed state, means from active to failed state. In partially committed state also, if failure occurs while writing changes in database, then also it enters in a failed state. Means transaction can enter in a failed state either from active state if any problem occurs, or from partially committed state if any failure occurs while writing changes in a database system. Okay, so this is failed state of transaction. The next state is aborted state. When transaction enters in a failed state, that is, if any transaction fails, then changes made by those transactions need to be rolled back. Okay, see, whenever transaction is in execution, whenever transaction executes any command, all the changes are done in main memory instead of database, instead of disk. Okay, and if transaction fails, then we need to delete all those changes from the memory. We need to roll back the transaction. Okay, so after rollback of all changes in a memory, transaction enters in a aborted state. When we roll back a failed transaction, we say that transaction is in aborted state. And after aborting any transaction, after rollback of any transaction, the recovery module in database either kill that transaction or restart the transaction, okay, for the next execution. The next state is committed state. When all changes are made permanently on a database in a disk, then we can say transaction is in committed state. See, in partially committed state, the changes are done in main memory. And when we reflect all those changes in database, and when we write commit command to store those changes permanently, then transaction is in committed state. Okay, and this committed state indicates a successful execution of transaction where all modifications are reflected on actual database. Now modifications are not there in main memory, they are actually reflected on a database. Okay, that's why transaction is said to be in a committed state. Then last state of transaction is terminated state. In terminated state, the transaction enters after successful execution or after abort operation. Okay, when the transaction is successfully executed, that is after committed state, or when we roll back transaction, that is after abort state, the transaction enters into a terminated state, and this is a final state of transaction. Okay, so now we have seen six states of transaction. First is active state, then partially committed state, failed state, aborted state, committed, and terminated state. Okay, now we'll see what is concurrent execution of transaction. In transaction processing system, multiple transactions are running concurrently or simultaneously in a system. Okay, so when multiple transaction access or update data simultaneously, it is called as a concurrent execution of transaction. Okay, if multiple transactions are accessing different parts of database, then we can execute those transactions concurrently. Okay, means concurrent execution of transaction is transactions are executing at the same time and possibly they access different parts of database. Okay, that is concurrent execution of transaction. So we have some advantages of concurrent transaction execution. The first advantage is decreasing waiting time. Okay, see, when we work with the transaction processing system where multiple transactions are running concurrently, we can have a mixture of transaction. That is, some transactions may be of short length and some may be of long length. Okay, so these types of transactions are running in a system concurrently. So in serial execution of transaction, short transaction has to wait for previous long transaction to complete, and it results in an unpredictable waiting time for a short transaction. See, when we have number of transactions, some of them are short length and some of are long length. Okay, and if we run this transaction, if we execute this transaction serially in a system, then sometime maybe short transaction has to wait for the long transaction for the completion. Okay, so by running all these transactions concurrently or simultaneously, if they are not accessing the same part of database, we can decrease the waiting time of short transaction. Okay, in concurrent transaction, multiple transactions can run concurrently, can run simultaneously. By sharing CPU and disk among all the transaction, we can decrease the waiting time of transaction. Okay, so this is the advantage of concurrent execution of transaction. The next advantage is increased throughput. Here in concurrent execution system, multiple transactions are running concurrently, they are executing simultaneously, so it increases the output of system. Okay, so multiple transactions can complete their execution at the same time and they can produce their intended result. That's why the throughput or the output of system also increases. Then next advantage of concurrent execution is better resource utilization. Now in computer system or in computing system, the resources are hardware resources, software resources, disk, CPUs. Okay, so these are the resources of system. With concurrent transaction execution, we can have a better utilization of these resources. That is, whenever any transaction runs in a system, that transaction may consist of IO activities. That is, that transaction wants to communicate with the IO devices, or they consist of some CPU activities. That is, they require CPU resources, they require CPU for the calculations. Okay, so IO activities of one transactions can be executed in parallel with the CPU activities of another transaction, and this is called resource sharing. Now here we have two types of resources. We have CPU and we have IO devices. Okay, and then if one transaction is executing some instructions with IO devices, if one transaction is accessing some IO device, then simultaneously another transaction can perform operation with the CPU. Okay, this is called resource sharing. And by executing transaction in parallel manner, by executing transaction concurrently, we can have a better resource utilization. Okay, and because of this strategy, no resource remains idle for a long time. Okay, and transactions are executed faster. So these are the advantages of concurrent execution of transaction. First, the decreased time it decreases the waiting time of short transaction. Then it increases the throughput, that is output of system, and it has a better resource utilization. Now we'll see what are the problems with concurrent execution of transaction. See, each system has some cons and some pros. Each system has some advantages and disadvantages. Now we have seen the advantages of concurrent execution of transaction. Now we'll see the problems that occurs while executing transaction concurrently. So the first problem is dirty read problem. Okay, in dirty read problem, if one transaction updates the value of any item and if that transaction fails, but another transaction reads that updated value before failed transaction is rollback. Now we know whenever any transaction fails in a system before commit, if any transaction fails in a system, then we need to roll back that transaction so that we can undo all the changes done by that failed transaction. Okay, so if in a system any transaction has updated value of some item, value of some variable, and after updating the value of that variable or after updating the value of that item, if that transaction fails, then we need to roll back that transaction. But before rollbacking, if that updated value is read by another transaction, then it is called as dirty read problem. Okay, for example, here we have two transactions, transaction T1 and transaction T2, and time cycle is also mentioned here. Okay, so here in transaction T1, it is reading a value of account A, it is deducting amount 1000 from account A and again writing updated value to the account. Okay, now here again transaction T2 is reading value of A, it is crediting rupees 2000 to account A and then it is updating the value of account A. Now here, if transaction T1 fails at 7th time cycle, that is at time cycle 7, if transaction T1 fails, then it is required to roll back that transaction to undo all the changes done by it. But before rollback, transaction T2 is reading the value of A at time cycle 4. Okay, and the value is updated by T1, but T1 is failed, it is not committed. Still T2 is reading the value which is updated by transaction T1. Means T2 is reading incorrect value of account A. This is called as dirty read problem. In dirty read problem, two transactions are running simultaneously in a system and one transaction updates some value then fails, and second transaction reads the value of item which is updated by failed transaction. Okay, so this is called dirty read problem. The next problem in concurrency is lost update problem. That is when multiple transactions are executing concurrently in a system, an update done by one transaction is overwritten by update done by another transaction. Then it is said that there is a lost update problem. For example, here you can see again we have two transactions T1 and T2. T1 is reading value of A, then it is updating value of A. T2 is again reading value of A at time cycle 4 and it is updating value of A with rupees 2000 and then it is executing commit command. Okay, now here T1 is updating a value of A at the third time cycle in main memory. Okay, but T1 is not completed. T1 is not committed because T1 is having more instructions to execute. Okay, and here T2 is also updating the value of A at 6th time cycle. See, in T2 at 6th time cycle, it is writing a value of A. And immediately after writing that value at 6th time cycle, it is committing at 7th time cycle. Okay, means here before updating the value of T1 in a system, the system is updating the value of T2. Okay, this is called as lost update problem. Here, due to this commit of T2 transaction, the value updated by T1 transaction is overwritten by the value updated by T2 transaction. This is called as lost update problem. Here in this example, first T1 is updating the value of account A. Okay, but T1 is not committed. Again, T2 is also updating the value of account A, but before commit of T1, T2 is committing. That is, T2 is storing the value of A permanently in a database. Okay, means here the value of A, which is updated by T1, is overwritten by the value of A, which is updated by T2. This is called as lost update problem. Here, the update done by T1 is lost by the update done by T2. Okay, so this is the problem of concurrency. Then we have another problem, that is unrepeatable read problem. Here, this problem occurs when one transaction reads different values of same variable in its different read operation. If any transaction consists of multiple read operation, then at each read operation, if that transaction is reading different value of same variable, then it is called as unrepeatable read problem. That is, that transaction is not getting same value at each read operation. For example, here we have two transactions T1 and T2. Now both the transactions are reading value of variable A or reading value of account A at the same time, that is at time cycle 1. Okay, but here in third time cycle, T1 is updating the value of A. Okay, and in fourth time cycle, T2 is again reading the value of A, but here T2 will get a updated value which is updated by transaction T1. Means T2 transaction is getting two different values of account A. At time cycle 1, T2 will get a different value, and at time cycle 4, it will get a different value. Because at time cycle 1, T2 is reading the initial value of account A. And meanwhile, that value is updated by transaction T1. Then at time cycle 4, it is reading an updated value of account A. Now at time cycle 1, T2 is having another value of A, and at time cycle 4, T2 is having another value of A. This is called as unrepeatable read problem, where one transaction consists of multiple read operation, and at each read operation it is getting a different value. Read problem. Here in phantom read problem, when one transaction read a value of any variable for the first time, and after some instruction, if it again tries to read the value of same variable, then it finds that the variable does not exist in a memory. That is, the variable deleted from the memory. This is called as phantom read problem. Here we have two transactions, transaction T1 and transaction T2. Both are reading the value of account A at first time cycle, and at third time cycle transaction T1 is transaction T1 is deleting the value of A. Okay, means now A item or A variable is deleted from the memory. And in fourth time cycle, transaction T2 is again reading the value of A. But since that A is deleted by T1 in third time cycle, in fourth time cycle T2 will not get the value of A in a memory. It will get an error that A doesn't exist or A is deleted from the memory. Okay, this is called as phantom read problem. Phantom read problem occurs when one transaction is reading the value of same variable number of times, but sometime that transaction will get the value of variable, and next time it will not get the value of that variable because the variable is deleted by some another transaction. Okay, so this is called as phantom read problem. And all these problems are need to be rectified. All these problems are need to be removed from the system so that we can ensure consistency and integrity of database management system. And in database management system, we have various concurrency control protocols by using which these problems can be prevented. These concurrency related problems can be removed from the system. Okay. So in today's session, we have studied about states of transaction, concurrent execution of transaction, then advantages of concurrent transaction execution, and the problems that occurs while executing transaction concurrently. So the problems are dirty read problem, lost update problem, unrepeatable read problem, and phantom read problem. In next session, we will study about schedules in database management system. Thank you.